All right. Hi, everyone. My name is Shay. As Brian mentioned, I'm Director of Product Marketing for Synaptics. I'm responsible for low-power AI. And the topic of my presentation today is multimodal edge AI sensing, and specifically how to enhance edge AI vision with our Katana chip for using multimodal edge AI sensing. And so computer vision has been around for a while, obviously. I'm sure a lot of you have been involved with it for quite many years. Specifically, AI-based computer vision, of course, solving problems such as image classification, object detection, tracking, identification. Those are classic problems for computer vision. And in recent times, I guess we've probably all seen, I know I have seen, starting to see implementations of AI computer vision in edge devices, in embedded devices. Now, I personally am pretty new to computer vision, honestly, but I've been involved in embedded audio for many, many years. And in recent years, specifically in edge AI embedded audio, so audio edge AI. And when I started getting involved in vision edge AI, what I realized is that vision edge AI, it provides a far more capable understanding of the environment in many cases. So it has many more things that you can do with it than with just audio edge AI. But at the same time, if you're just using vision edge AI as a single modality, if you're just using vision to try and understand what is going on around the device that is in the field somewhere, you're missing a lot of contextual information. You're missing information about what's going on. You're missing knowledge that otherwise could be available if you had the right sensing capability. And so I compare that to how I talk about my daughter. I have a 9-year-old daughter, and I compare that to how I talk to her about crossing the street. So I'm teaching her to cross the street now, and I tell her, hey, you get to an intersection, look left, look right, look left again, but also listen, right? Open up your ears, not just your eyes. You might hear a car coming fast before you even see it. So for her safety, I'm really making a point of that. And I think for a vision edge AI device, or for, I guess I should say, an edge device using vision, if it's only using that vision to understand what's going on, it's missing a lot of context, and that is similar to trying to cross the street with your noise-canceling headphones on, right? And I definitely ask my daughter not to do that, and not just because of the horrible music she listens to, but because it's actually a safety issue. And so that's one major problem with just using vision for these kinds of edge AI applications. The other problem with only using vision is if you don't want to miss any events, you have to keep your device always on, right? Always connected to a camera, processing the information, running your AI algorithms and figuring out what's going on based on that vision capability. And if it's always on, it's drawing a lot of power, and you're not going to be able to run off of batteries. It's going to have to be connected to power line. And that creates a scalability problem, right? In a commercial environment like a store or a factory, there's not always power lines available everywhere. And if you want to install multiple devices in a single premise, a single factory, a single store, or something like that, it costs a lot of money to draw those power lines, and sometimes it's not even possible. And in a consumer environment, of course, some of us have the ability to draw power lines in our homes. I know I don't. And I think that definitely creates a major issue with basically not enabling DIY, do-it-yourself model of deployment. So basically, the company that provides you with a device or with a service has to send someone in to install the device for you, or the multiple devices around your home. And so that has costs associated. Again, it creates a scalability problem.